Hello students, welcome back. That is the numerical. So, there is an object and that object is placed at, in the first case at a distance of 10 centimeter and second one is at a distance of 5 centimeter in front of a concave mirror of radius of curvature 15 centimeter. Now, the radius of curvature is given and that radius of curvature is 15 centimeter. You are asked to find the position, nature and magnification of the image in each case. That means, you have to find out the image distance and after finding out the image distance you need to find out the magnification and you have to state whether there is a magnified image or there is a diminished image or is it a real image or the virtual image. And as you know that the real images are inverted and the virtual images are erect. And suppose you get the magnification negative, then the image is a real image, and suppose the magnification is positive, then the image is the virtual image. So, we will check all these things and we will solve it by using the formula. Similarly, we will draw the ray diagram so that would help you in understanding the concept well. So, in the beginning, let me draw the diagram first, then I will solve it. So, that immediately you can say whether it is a magnified image or the diminished image or you can say whether it is the real image or the virtual image. Let me draw the rough diagram. First I will draw the diagram, then I will solve the numerical with the help of equation, and it is a concave mirror and it is a pole. The straight line through the center up to the center, that gives the radius of curvature, and the straight line passing through the axis, that gives you the principal axis. Somewhere here you have the principal focus, you know the relation between the radius of curvature, that is from P to C, and the focal length, the distance from P to F, and you know that focal length is half the radius of curvature. And for the concave mirror, the focal length is negative, right. Therefore, f is equal to minus r divided by 2. The focal length is minus r by 2. The radius of curvature is 15 centimeter divided by 2. Therefore, the focal length is minus 7.5 centimeter. It is given that it is a concave mirror. For the concave mirror, the focal length is negative, minus 7.5 centimeter, that would be the focal length. Now, the distance from P to F is 7.5 centimeter and the distance from F to C is also 7.5 centimeter. Now, according to the question, the object is placed at a distance of 10 centimeter. First, let me consider that distance 10 centimeter. And as you all know that the distance is measured from the pole, and therefore, the object is beyond the focus, but it is in between C and F. Somewhere here you have the object, that is AB. Now, you can draw the corresponding ray diagram. One of the rays parallel to the principal axis, the ray parallel to the principal axis, it passes through the focus, and another ray which tends to pass through the center of curvature, that retraces its path. So, after retracing path, that ray would travel in this direction, and this ray is moving in this direction, and these two rays will meet at a particular point, forming the image, that is A dash B dash. Now, what about the height of the image? The image height is greater than the object height, therefore, you need to get the magnified image, right. You get a magnified image, and when you solve the numerical using the formula also, you have to get the magnified image. The value of m should be greater than 1, the magnitude of m should be greater than 1. And the rays, they actually meet at a particular point. Since the rays actually meet at a point, the magnification should be negative, and the negative value of the magnification indicates that the image formed is the real image, and from this you can infer that it is the inverted image. Now, you need to find out the position, that means the image distance, you need to find out the nature, you know that it is inverted, and you have to find the value of magnification. Now, focal length you found out, the focal length that comes out to be minus 7.5 centimeter. So, object distance is also given, the distance from P to U, that is equal to 10 centimeter, but the distance is measured from P to A, and the ray is actually moving to the right, but the distance is measured to the left, therefore, the object distance is negative, which is minus 10 centimeter. So, I will write the parameters here, the object distance is U, that is equal to minus 10 centimeter. I will not convert that into meter, I will write as such, and I will get the value in centimeter itself. And image distance, you are asked to find image distance V is equal to how much. Then you know the focal length you have calculated that focal length F is equal to minus 7.5 centimeter. So, you have to find out the image distance. For that, you know the formula, that is 1 by F is equal to 1 by U plus 1 by V, that is nothing but the mirror formula. What you have to find is the value of 1 by V. 1 by V is equal to 1 by U minus 1 by F. So, 1 by V is equal to 1 divided by U, U is minus 10 minus 1 upon the focal length is minus 7.5. Focal length is negative, therefore, 1 by V is equal to minus 1 by 10 plus 1 upon 7.5. So, you can take the LCM here, the LCM is 15, sorry, 30 will be the LCM, 30 is the LCM. So, it is minus 3 plus 7.5 and it is 4. So, 1 by V minus 1 by V. I have taken this minus 1 by this 1 by V to the left. So, it is minus 1 by V, here also it is minus 1 by V. So, minus 1 by V is equal to 1 divided by 30, that means the image distance V is equal to minus 30 centimeter. So, I have taken this 1 by V to the left, therefore, it becomes minus, and this F to the right, therefore, it becomes plus. So, the image distance is minus. So, the image distance negative, that indicates that the image is formed on the side of the object. Object is here and the image is there on the side of the object, therefore, the image distance is minus 30 centimeter. Now, which one is greater, the object distance is greater or the image distance is greater? Clearly, you can say that the image distance is greater, hence you can find the magnification. So, we will find the magnification. You know the expression for the magnification. Magnification is equal to minus V by U. Once again, you need to apply the formula. M is equal to minus V by U, and you need to apply the sign convention also. So, it is minus of V, the image distance is minus 30 divided by the object distance is minus 10. So, the magnification is minus 3. So, what does it indicate? Now, the height of the image is 3 times the height of object. So, that is the meaning there, and the negative sign indicates that the image formed is real, inverted and magnified. Real, inverted and magnified. So, that is the nature. Okay. Hope this concept is clear. Next we will study it for a distance of 5 centimeter. Let me draw the diagram first, the pole, focus, then the center of curvature. You know the distance from pole to the focus, that is nothing but the focal length, that is minus 7.5 centimeter. But if you consider the second case, the object distance is 5 centimeter. I will write here the object distance. Object distance is u, that is equal to 5 centimeter, and the focal length, I have not applied the sign convention, I will apply it soon. So, the focal length f, that is equal to minus 7.5 centimeter, and I need to find the image distance, and the image distance is v, that is equal to how much. Now, the object distance is 5 centimeter. Since the object distance is 5 centimeter, where the object lies? Will it lie between P and F, or between F and C, or is it beyond C? Yes. Since it is 5 centimeter and all the distances are measured from the pole, the object lies at a distance of 5 centimeter from the pole. That means it is in between P and F, since the distance from P to F is 7.5 centimeter. But the object distance is 5 centimeter, hence it lies at this point in between P and F, and you know the nature now, right. So, whenever the object lies between P and F, the nature of the image is virtual and it is enlarged, magnified. So, one of the rays parallel to the principal axis, the ray which is parallel to the principal axis, it passes through the focus, and another ray that is intend to pass through the center of curvature, it retraces its path. Hence, these rays when they are produced, they meet at a particular point. The produced rays, they meet at a particular point. You can also consider a ray that is passing through the pole and that is extended in that direction, so that they meet at a particular point. And you know that the image is formed behind the mirror, behind the silvered surface of the concave mirror. Hence, you know that the nature of the image is the nature of the image is virtual and it is erect, and you can also see that the height of the image is greater than the height of the object, that is AB. Hence, you can say that it is the magnified image. So, this explanation based on the ray diagram. Next, we will obtain that using the formula. So, the object distance is measured in the direction opposite to the direction of the incident light. The distance is from P to A, that is opposite to the direction of incident light. Therefore, the object distance is negative, hence it is minus 5. We will use the formula, that is 1 by F is equal to 1 by U plus 1 divided by V. What we want? We want 1 by V. Therefore, 1 by V is equal to 1 by F minus 1 by U. Now, 1 by V is equal to F is minus 7.5 minus 1 upon minus 5. Therefore, 1 by V is equal to minus 1 upon 7.5 plus 1 divided by 5. So, 1 by V, I can take LCM. LCM is equal to 15. 15 will be the LCM. Therefore, it is minus 2 and this is plus 3, right. So, 1 by V is equal to 1 divided by 15, therefore, the image distance is equal to 15 centimeter. And now, the image distance we obtained as plus, that means the distance is measured along the direction of the incident light, the distance from P to A dash, the distance is being measured along the direction of the incident light, which is positive, right. So, V is equal to 15 centimeter. We will find the magnification. Magnification M is equal to minus V divided by U, that is minus of V, the image distance is plus 15 centimeter, and the object distance, that is minus 5. So, this minus and this minus gets cancelled, or minus of minus, it becomes plus. So, 15 by 5, that is equal to 3. Now, the image distance is positive and the magnification is also positive. What does it indicate? It indicates that the image formed is virtual, the image formed is virtual, erect. Magnitude of M is greater than 1. Since the magnitude of M is greater than 1, is magnified. That means height of the image is 3 times the height of object. Magnification is equal to 3, that indicates that the height of image is 3 times the height of object. We will solve one more. So, here is the second one. A 4.5 centimeter needle is placed 12 centimeter away from a convex mirror of focal length 15 centimeter. Give the location of image and the magnification. That means you are asked to find out the image distance as well as the magnification. As you all know that whenever you use a convex mirror, the image formed is erect and it is virtual and it is diminished in size in the case of convex mirror, which is also used as side view mirror in vehicles, right. So, you know that its magnification is less than 1, the value of magnification is less than 1, but we will find out the exact value. Before that, we will draw the diagram, and in the case of convex mirror, the reflection takes place from the outer surface and the inner surface is silvered, and here somewhere here there is a pole, and here there is a focus and there is a center of curvature, and the reflection is taking place from the outer surface. Now, the focal length is given, focal length is 15 centimeter, that is the distance from pole to the focus, that is equal to 15 centimeter. We will check whether it is positive or negative. That is this much distance, that is nothing but the focal length. And also the object is placed 12 centimeter away, that means along this direction. It cannot be placed inside because it is not the reflecting surface, only this is a reflecting surface. Hence, the object is placed somewhere here, right. And one of the ray, this object distance is 12 centimeter. One of the ray from the object is made to incident on the mirror, and it is parallel to the principal axis. Since it is parallel to the principal axis, it intends to pass through the focus. It tries to pass through the focus. So, this is a reflected ray, and when it is produced, it passes through the focus. And another ray which is directed towards the center of curvature. So, this ray is directed towards the center of curvature, and the one which intends to pass through the center of curvature or actually passes through the center of curvature, that retraces its path. It retraces its path. So, these two rays, when they are produced, they meet at this point, that is A dash, B dash. So, the produced rays meet. Since the produced rays meet, you know that the image formed is virtual, right, and the height of the object is more and the height of the image is less, therefore, it is the diminished image. Now, you need to find out the distance from P to A dash, the image distance, and the object distance is from P to A. and this object distance is measured in the direction opposite to the direction of the incident light. The incident light is from right to left, while the object distance is from left to right. Therefore, the object distance is negative, and the distance from P to F that is measured along the direction of the incident light. The incident light is from right to left. Similarly, the distance from P to F is also from right to left. Therefore, the focal length is positive. While in the case of concave mirror, the focal length was negative, and in the case of convex mirror, the focal length is positive. That is the important thing that you need to remember here. So, we will solve it. First, we will write whatever is given, that is object distance u is equal to minus 12 centimeter, focal length f is equal to 15 centimeter, and it is positive. You have to find the image distance. We use a mirror formula, that is 1 by f is equal to 1 by u plus 1 divided by v. What we need is v, therefore 1 by v is equal to 1 by u minus 1 divided by f. Hence, 1 by v is equal to 1 divided by u. U is minus 12 minus 1 upon 15. So, this is minus 1 by v. So, minus 1 by v, that is equal to 1 upon minus 12 minus of 1 by 15. So, minus 1 by v is equal to 60 is the LCM. Is minus 5. So, minus 1 by v, that is equal to minus 9 divided by 60, or 1 by v is equal to 9 by 60, or the image distance, that is equal to 60 divided by 9, which is nothing but 20 by 3. 60 by 9, that is 20 by 3. 20 by 3 is 6.67 centimeter. The image distance is 6.67 centimeter here, which is measured along the direction of incident light. Next, we will find the magnification, and the magnification m is equal to minus v divided by u, that is minus of image distance. Image distance is 6.67, or let me write it as 20 by 3, 20 by 3 divided by the object distance. Object distance is minus 12. So, this is minus of minus, that gets cancelled. So, this minus and minus gets cancelled. So, it is 20 divided by 36, 12 into 3, that is 36. 20 by 36 is 5 by 9. Therefore, the magnification is plus 5 by 9, which is less than 1. 5 by 9 is less than 1. Hence, the image formed is diminished, and the magnification is 5 by 9. That is all from reflection, and you can solve some more numericals. And if you have understood these two concepts clearly, whatever the numericals that is given in this chapter regarding reflection, that you can solve it very easily. And there is one more formula for magnification, that is m is equal to hi by ho. There also you need to apply the sign convention, and hope all of you are the masters in applying the sign convention, and have a good day. Thank you.